We're going to look at problem 119. Now 119, again, your numbers may be different because Mastering Physics randomizes the number. But it's working with some conversion factors that, if I check my sheet here, might not be on the front sheet in the textbook. Let me verify that instead of saying that, as I have my copy here. We do have a light year to meter in the front of the textbook. But what it wants to do is it wants us to calculate the light year. And so we do have a light year to meter, and then we need to get an astronomical unit, which is not on the unit conversion. We do have a parsec, which my work I measure kiloparsecs. The sun is about 8.5 kiloparsecs from the center of the galaxy, about 24,000 light years. And we're going to have an idea of what that means. But we're going to look at it in the case here. My problem says a light year is the distance light travels in 1 year at a speed of 2.998 times 10 to the 8th meters per second. An astronomical unit is the average distance from the sun to the earth, which is 1.5 times 10 to the 8th kilometers. And 1 year is 3.156 times 10 to the 7 seconds. So they're giving us enough information that even if we didn't have the conversions, we could work this out. And so what we do here is, the first thing is, how many meters are there in 5.1 light years? So again, your problem's probably going to have the same conversions written up top. But it will probably have a different number than 5.1 light years, but the same thing is going to happen. So we have 5.1 light years. Now, light year is the distance in meters that light travels in a year. So what we can do is we can take 2.998 times, yeah, I get my time symbol right, 10 to the 8th meters per second. I want to put seconds down beneath because per means division, per second. And so I have a light year, meters per second. I need to get rid of this year somehow. So let's see. 1 year is 3.156 times 10 to the 7th seconds. And so by using all those definitions I was given, I have a year canceling a year, a second canceling a second, and I'll be left with meters. So year, year, second, second. And so I want to multiply straight across here. So I'll again pull up, oops, didn't mean to, looks like my mouse button is stuck there a bit. Let's get off of that there, clean that up a bit, come down here. And can I get to a point where I can get my calculator up here? So let's multiply this across. And come on, calculator. There we go. There's the calculator. Alright, so let's move this down here. So I'm going to multiply across here 5.10 times 2.998 times 10 to the 8th times 3.156 times 10 to the 7th equals 4.825 times 10 to the 16th. But let's look at our sig figs. all of these are conversion factors. So the only thing that matters for sig figs was what we were given. And I was given 3 sig figs. So I want the first 3. 4.82, but it's a 5, so it rounds up. So 4.83 times 10 to the 16th meters. So we'll write that in here. 4.83 times 10 to the 16th meters. And so that's the distance in 5 light years. Well, next it's I'm getting asked for part B. For part B here. Part B, how many astronomical units there are. And so it's saying that an astronomical unit, 1 AU, is equal to 1.50 times 10 to the 8th kilometers. And what we're going to do is we're going to take that kilo being 10 to the 3rd, and we're going to make it 1.50 times 10. Well, if we're grabbing a 10 to the 3rd, and in this case it's a positive, so I'm going to make that times 10 to the 11th meters. And so now I want to convert AU. I want to convert my AUs that I have over here from meters. So I want to start with 4.83. 4.83 times 10 to the 16th meters. I wanted an AU, so I put 1 AU up top. And my conversion factor says I'm going to have 1.5 times 10 to the 11th on the bottom. 1.50 times 10 to the 11th meters. Well, my meters will cancel, so what I have left will be in astronomical units, AU. So let's get my calculator out again. I keep losing this here. Let's see. Applications, there's calculator. There we go. So I want, let me pull this up here. Can you see? Yep. So 4.83 EE gives me 10 to the 16th, divided by 1.5 EE 10 to the 11th, and I have 322,000. So if I count decimal places, 1, 2, 3, 4, 5. So 3.22 times 10 to the 5th AU. And if we look at our original answer, it was in 3 sig figs. This is in 3 sig figs. So we have a good solution here. And it lets us work with conversion factors. Now, we could have used the definition of 1 light year equals 9.461 times 10 to the 15th meters and place that in place of the conversion factor we did. In the spirit of the problem, because the problem gave us the information that we didn't need to look on our table to do this, I used the problem to generate those. You can go either way. As long as you're comfortable creating conversion factors from the unit conversions that are given in the front of the book, that sheet you will have for your exams, and you're able to take that with you.